we're going to prepare for graphing trig functions by looking at our unit circle and applying that unit circle to values that will plot and see the pattern of what sine and cosine graphs look like. So our objective is to be able to use the unit circle to transition to graphing trig functions. So this first one, what I want to do is fill out a chart from, you might have these values memorized, or you might use a unit circle. We can use this unit circle right down for this graph introduction. Notice down here in the first quadrant, we've got values that we can pull off for this table. So first of all, 30 degrees in radians, it's listed here. 30 degrees is pi over 6, or you could use the formula of multiplying by pi over 180 to translate it to radians. Now if we look for sine, notice that cosine is the x, sine is the y, these ordered pairs. So if I look at the sine of this 30 degrees, I'm going to use 1/2. And then cosine is going to be the x value, it's going to be square root of 3 over 2. Now tangent, we have to calculate. And what we're going to do is we're going to use the fact that tangent of theta is going to equal sine theta over cosine theta. This is an identity that we can use to calculate tangent. So now let's go ahead and do this one. If you look at the process, I'm going to take sine and put it over cosine. So I'm going to take 1/2 over square root of 3 over 2. Now when I have a fraction over a fraction, I multiply by the reciprocal of the denominator. So I flip that over and multiply. The 2's will reduce. And so you end up with 1 over square root of 3. Now we really need to use the process we learned with radicals of rationalizing denominators. So we're going to multiply this by square root of 3 over square root of 3. And so we get square root of 3 over square root of 9, which is just 3. So that's our value for tangent. All right, let's move on. I'm going to move down to the 60 degree, because why I'm moving down to 60 degree is because sine and cosine relate to this because those are complementary angles. So if I look at this, I make this a pi over 3. When I look at 60 degrees, that's pi over 3 in radians. And I could just look at the x and y here, but notice, since 60 and 30 are complementary, sine of 30 is the same as cosine of 60. So those two are the same. And sine of 60 is the same as cosine of 30. So I can write this one here. So notice that these values, when we start with these, I can use the other complementary angles in order to find these values. But again, you could look at your unit circle. All right, let's do 45 degrees. 45 degrees is pi over 4 in radians. And then if I look at my ordered pairs, both x and y are square root of 2 over 2. That makes sense because 45 is its own complement. And so sine and cosine, co-functions, they're going to have the same value. Now let's look at our tangent. Let's go down to this one first of all. 60 degrees here. If I use it, I'm going to put the 1/2 over. I'm going to put sine over cosine. So square root of 3 over 2 over 1/2. That's the reciprocal of this one. Notice. And so since it's the reciprocal of this one, I'm going to just take this value here before I rationalize the denominator and flip that one over, and I get the square root of 3. So you could do it if you want to go through the work of putting in square root of 3 over 2 over 1/2 and rationalizing, and simplifying. Now tangent, notice that when I put sine over cosine, these are exact same values. You're going to get 1 for this one. All right, so that's filling in a table, getting used to these unit circle values. Let's go ahead and use this information to help us. We're going to use our unit circle to help us with getting these values, and then some more complicated ones. We'll do them all together here. But you look at sine of 150, you go to and find 150 on the chart here. And I want sine, so it's going to be the y value here. So sine of 150 is going to be equal to 1/2. Now if if I want cosine of 7 pi over 6, notice here's 7 pi over 6. I want cosine of it, so that's the x value. So I'm going to get negative square root of 3 over 2 as my value. Now this agrees with where we also know our sines, cosines, and tangents are positive in which quadrants. Sine is positive in both the first and the second because those are the y values that are positive. Cosine is positive in the first and the fourth because that's where x is positive. And so that's the reason why we have a negative for cosine here in the third quadrant. All right, let's do tangent of 225. If we look at this one, looking at our unit circle, I'm going to go to 225 here. And notice if I put these two values over each other, put sine over cosine, I get negative square root of 2 over 2 over negative square root of 2 over 2. Those are the same values, so that's going to equal 1. And remember, tangent is positive in the first and the third quadrants as we review that. And lastly, let's do cosecant of 5 pi over 3. Let's find 5 pi over 3. It's right over here. Now, this has sines and cosines on it. Cosine comma sine for it. Cosecant is the reciprocal of sine. So this is going to be 1 over sine of 5 pi over 3. So let's go ahead and find sine, and we're going to do its reciprocal. So notice that the sine here is the second value, it's the y value, so I'm going to do its reciprocal and make that equal to 2 over negative square root of 3. The negative can go wherever I want it to. I'm going to rationalize the denominator. So I'm going to pull the negative out in front of the whole fraction. And so in the top you get 2 square roots of 3. On the bottom you get the square root of 9, which is equal to just 3. All right, so that's my answer for cosecant of 5 pi over 3. All right, just circle all my answers here. Now, let's go ahead, now we've gotten used to the unit circle, let's go ahead and transition to graphing the sine and cosine. We need some information that will help us, some vocabulary for doing the graphs. And this is really important vocabulary as we do more of these graphs, this vocabulary will come into play. First of all, the word period or cycle, that answers the question, how long until the graph repeats? All right, then the frequency is going to be the reciprocal of period. So once you see how long it takes to repeat, get that value, and then you take its reciprocal for frequency. Now midline, all it means is if you've got a graph going, and these are going to tend to look like waves. If you've got a graph going, you look at the top point and the bottom point, and the midline is just halfway between them. So halfway between the top point and the bottom point. And then lastly, amplitude we'll use quite a bit also. So we're going to use midline in this. If you look at the midline, it's how far to the top of the graph. It's technically how far it is to the bottom of the graph as well, but from the middle, how far to get up to the top. So distance from the midline to the max point. All right, now, once we've got that vocabulary, let's go ahead and take this. And what I'd like you to do is I'd like you to go through this exercise, make sure you're in degrees on your calculator, and take the sine of each of these angles. So take the sine of it and write a decimal. If you have to round maybe to 2 decimal places, Put those in there because we're gonna plot these points on the graph. So go ahead and pause the video, use your calculator, fill in these values. Now that you've filled in these values, hopefully you see the common numbers that keep showing up, sometimes near each other, sometimes with the opposites, but the repetition of these values show that these trig functions have a lot of repeating values coming up in their values, in their y values. So let's go ahead and plot these points. So if I plot 0, 0, I start here for sine. I go to 30 degrees, go up to 0.5. For 60 degrees, I go up to 0.87, so right about there. 90 degrees up to the top, then 0.87 to 0.5 again for this, and then back to 0. So notice that this first part looks like this. It's a curve that goes up and then peaks and then comes back down. Let's plot the other ones. Negative 0.5 at 210, then negative 0.87, negative 1, negative 0.87, negative 0.5, and back to 0. And so notice we see that same curving graph in this direction. This is what sine looks like. It's called a sine curve, and it's got a repeating pattern to it. If we were to pick up at 360, the pattern would be repeated. So we have a period here of 360 degrees, and notice we have a amplitude from the middle up to the top is just 1. So we've got some values here we can use. Now let's go ahead and do cosine. We're not going to set up a chart for this. We're going to actually start with understanding that repeating values and then the connection between sine and cosine. Since cosine is the co-function of sine, complementary angles, what I have for starting at 0 degrees, what's complementary with 0 degrees? Well, 90 degrees is complementary with it. So we're going to start where this one starts at 90, and then it will just have the same values. So starting this one up at at 0, we start up at 1, where 90 degrees was here, and then we just have the same repeating pattern, 0.87, 0.5, 0, negative 0.5, negative 0.87, negative 1, negative 0.87, negative 0.5, and 0, and then 0.5, 0.87, and then 1. And so the graph will look like this. It's just the sine graph shifted over a bit. So if we take this part of it and shift it over to the origin, we have our cosine graph. So we've looked at the unit circle and saw how values repeat on it, came up with a chart, did some simple values looking at the unit circle to how you get those values off of the unit circle, and just to do some examples. And then what we did was we went ahead and graphed a series of points on this to see how this graph for sine repeats, the repeating patterns also in cosine, and then we'll go ahead and move on to get more information about sine and cosine upcoming after this introduction, and then later look at the other trig functions graphs as well.